Alright, so today we're going to be looking at what happens if we're adding or subtracting algebraic fractions. And it is, again, exactly the same as if we're doing numerical fractions. We're trying to find a common denominator. So if we rewrite this little equation here that they want us to simplify as a single fraction, we first need to follow the steps we did when we were just doing numerical fractions, and that's to find ourselves a common denominator and adjust what we've got here. So first up, let's make this first one into a fraction. Okay, now what's a common denominator between these two numbers? Well, the easiest way to do that without overcomplicating it is just to multiply one by the other. That means we'll end up with something over 2 plus something over 2. Now, of course, the second term, nothing has changed. So we can put that back the way it is. But something has changed. To go from here to our 2, we've multiplied the denominator by 2, which means we have to do the exact same to the numerator, because otherwise we don't have an equivalent fraction. So we're also going to multiply this by 2, and we get 2x plus 2x over 2 plus x over 2. And now that they have the same denominator, we can simply add them across. So let's do that now. So 2x plus x is 3x, and then that's all over 2. Now, because there's no common factor here, we get to leave this the way that this is, and that's our answer to this particular question. Okay, so the steps there were really quite simple. We found a common denominator, and then we performed the operation, and then we looked to see if we could simplify anything, but we could. Okay, let's get some more spacing. Now, on the next one, we have the same idea. We have y over 4 plus y over 2. Right, so the first thing we're going to do is find a common denominator between the two. Now, obviously, we can change this to, we can make it a 4, and we can change the entire term. But you can also multiply the two of these together as well. It's really up to you how you want to approach this. One will just result in less simplification at the end. So if we just recognize that we have a common factor that can easily be achieved by having this be something over 4 plus something over 4, and because this is already over 4, we just leave it. Now all we have to do is recognize that to get from this to this, multiplied by 2, so you have to do the same to the numerator, and that means we'll get 2y. So because they now have the same denominator, we can add them both. Y plus 2y is 3y over 4. Now, what we have to remember when we're doing these things is that there is no immediately perfect way to do this. You can obviously find a better way, but if we went the other way and turned it into multiplying the 2 and ending up with an 8, we would just have to do some simplification at the end. Okay, on to our next one. M over 3 minus m over 9. So, again, we're going to be looking for a common denominator between these two, or the lowest common denominator between them, if we can. If we're going to list multiples of 3 and multiples of 9, the lowest one would obviously be 9. So we can start off with that, minus something over 9. And because this is already the same, we can just keep it. And to get from here to here, we've multiplied by 3, so we have to do the same to the numerator. Also, these arrows, I am only really using these as a guide or an illustrative thing. I typically don't do them, and you don't have to do them either. You can include them, but it's kind of a little bit of an extra step that you can just drop once you get the idea. Okay, now we have 3m minus m, and we have the same denominator, so we can just perform the operation on top. So 3m minus m is just 2m. And we can't simplify that any further, so that's our answer. Okay, so let's clear this off. All right, next one. N over 2 plus n over 5. So this is a little bit of a less obvious one, and both fractions will have to change. But if we listed out all the multiples of 2 and the multiples of 5, the lowest common one we would find would be 10. All right, we can possibly do that now if you would like. So 2, we have 2, 4, 6, 8, 10, and 5. We have 5, 10, and because we found a common point, that's our denominator we're going to use. Right, so what has happened to get from this point here to the 10? We've multiplied it by 2, so we have to do the same to our numerator here. We can't just leave it alone. So because we multiply that by 2, then this becomes 2n. All right, now this one here, we've done something entirely different. We've multiplied it by 5 to get it to 10. So we have to do that to this one as well. All right, so this becomes 5n. Now that we have both of these fractions converted to equivalent fractions with the same denominator, the 10, we can now add them across. So the 5 and the 2n become 7n, and we keep the same denominator, and we look for any opportunities to cancel, but there aren't any, so we'd leave it alone. All right. Now, if we look at this one, it's the same idea as well. Our first step is always to find a common denominator to change both of these into. Now, because we can't immediately multiply one and change it into the other, we have to find the lowest common multiple between them, okay? Now, the lowest common multiple between both of these is going to be 24. And we know that because we can list all our multiples, right? We can list 8, 16, 24. We can list 12, 24, and we find our earliest commonality between them. So we know it's going to be 24. We know it's something over 24 minus something over 24. And all we have to do now is make sure we're consistent. Whatever we did to the bottom, we have to do to the top. We multiplied this by 2. So we have to do the same to this y. And it becomes 2y. How did we go from the 8 to the 24? Well, the 8 to 24, we multiplied it by 3, which means we have to do the same for the x. Okay, now we can combine them together. Now, combine them together, we get 3x minus 2y all over 24. There's nothing here we can do because we can't actually perform this subtraction or the difference up here because they're not like terms, and there's no common factor between both terms that we can cancel with our denominator. So that's our answer here. All right, next one, we have 2a over 3 plus 3a over 2. So with this one, again, we're going to look for a common factor between them, and the lowest common factor between 3 and 2 is just going to be 6. Okay, and once that's done, we just check what we've done to the 3. What have we done to the 3? We've multiplied it by 2, so we have to do the same to the 2a, so it becomes 4a. Okay, and what we've done to the 2 denominator here to get to it to be a 6, we multiplied it by 3. So we have to do the same to this guy. We also have to multiply him by 3, and it becomes 9a. You can see how we're getting rid of the arrows, and that's a good idea. The arrows are kind of confusing. So 4a plus 9a over 6. The 6 stays the same. What's 4a plus 9a? Well, that's going to be 13a. Now, there is no common factor between this that we can cancel vertically, so that is our answer. Alright, so next one, we have 7b over 10 minus 19b over 30. Now this one's a little bit different. We can immediately find a value which is going to be able to be used simply. So if we know that the common multiple between these is going to be 30, well, we can leave that one the way it is in the second term exactly the same way. Right? We know 10 and 30 have a common multiple. So all we need to do is we've multiplied the 10 by 3 to get 30, so we multiply the 7b by 3, and 7b times 3 is 21b. Okay, now we've done that, we have 21b minus 19b all over 30. And the end result here will be 2b over 30. You can write out that as a separate step if you would like, but 2b over 30, now can we make this any simpler? And yes, we can. We can find a common factor between both of them. We can divide both the top and the bottom by 2. So dividing 30 by 2 leaves us with 15. Dividing 2 by 2 leaves us with 1. So in the end, we end up with 1 times b, which is just b, over 15. Every single time you do these questions, it's going to be the same. Find a common factor, perform the operation, simplify. Okay, here's our last one. So we have x, y over 30 minus x, y over 12. Now, what's the common factor between both of these? We can list out the multiples of 30. Well, we have 30, then we have 60. That sounds pretty good to me. And 12, we have 12, 24, 36, 48, and then we have 60. Right? So 60 is our lowest common multiple. We'll put that down here. Okay, or lowest common denominator rather. Now we've done that, we know what has to happen. We know that in order to get 30 to 60, we've multiplied it by 2. So we have to do 2xy. We know that to get from 12 to 60, we've multiplied it by 5. So we have to do minus 5xy. Now they are the same, so we perform our operation. 2 minus 5, they're both like terms. So we have 2 groups of xy minus 5 groups of xy. Well, that's negative 3 groups of xy all over 60. Looking for a common factor here to cancel, we can see that 3 does go into 3 and 3 also goes into 60. So I can divide the bottom by 3 and I can get 20, and divide the top by 3 and I get 1. And I end up with negative xy all over 1. So these can be kind of tricky and they can be kind of annoying, but the idea here is to just follow the steps every single time. And when you're getting started, take your time, be slow, draw the different multiples up the top, draw the arrows, do whatever you need to in order to make it work for you until you can get rid of them. Alright, that's it for this video. Hope it was helpful, and I will see you in the next one.